The sum of the interior angles of a convex polygon with n sides is given by sum is equal to quantity n minus 2 times 180 degrees. Let us have some examples. Okay, example number 1. Given a quadrilateral. So, we have here n is equal to 4. We are just going to write first the formula and substitute our n by 4. So, we will have sum is equal to quantity 4 minus 2 times 180 degrees. Let us just simplify. Of course, following the PEMDAS rule, parenthesis first. So 4 minus 2 equals 2 times 180 degrees equals 360 degrees. Therefore, the sum of the interior angles of a quadrilateral is 360 degrees. Okay, let us have another example. So in this given example, we have an 18 gon. Just as we have in our first example, we only need to substitute the n, the number of sides, to our given formula. So let us substitute n by 18 and then simplify. So 18 minus 2 equals 16 times 180 equals 2,880 degrees. Therefore, the sum of the interior angles of an eightagon is equal to 2,880 degrees. Okay, so let us have another example. In this given example, it is a pentagon. Smile, okay? And there are measurements given already here for angle S. Measure angle S equals 127 degrees. Measure angle M equals 129 degrees. Measure angle I equals 63 degrees. Measure angle L is equal to 126 degrees. Find measure angle E. So how are we going to find measure angle E? So we need to find first the sum of the interior angles of a pentagon. Using the formula, we can have it 540 degrees. Therefore, measure angle S plus measure angle M plus measure angle I plus measure angle L plus measure angle E equals 540 degrees. We already have the measurements for angle S, angle M, angle I, and angle L. So we just need to substitute it. No? And then after substituting, combined all the constant terms. So add 127 degrees plus 129 degrees plus 63 degrees plus 126 degrees. So it will be equal to 445 degrees. And after adding it, we just need to subtract it from the total 540 degrees. Therefore, measure angle E is equal to 540 degrees minus 445 degrees, which is equal to 95 degrees. Therefore, measure angle E is 95 degrees. Okay, so now we already learned how to get the sum of the interior angles of any convex polygon, whether it is regular or irregular. Now let us have the measure of one angle of a regular polygon having n sides. So to find the measure of one interior angle, we have here our formula, the sum formula a while ago. So quantity n minus 2 times 180 degrees overall n, or divided by n. Okay, so let us have an example. What is the measure of one interior angle in a regular hexagon? Okay, so this time around we have a hexagon. So if we have a hexagon, n is equal to what is the how many sides does a hexagon have? So we have 6. So we just need to substitute 6 to n. We will be having here measure of one interior angle is equal to quantity n minus 2 times 180 over all n. Or replace natin. We will replace n by 6. So we will have quantity 6 minus 2 times 180 divided by 6. Okay. So let us have the parentheses first. 6 minus 2 equals 4 times 180. So we will have 720 degrees divided by 6. So we have 120 degrees. Therefore, the measure of one interior angle of a regular hexagon is 120 degrees. All right. Okay. So what if we're going to find the number of sides of a polygon given the sum of the measures of the interior angles? Okay. We can derive a formula from our previous formula for the sum. So the sum formula is given by quantity n minus 2 times 180. So from this, we can derive a formula for n. Okay. So n will be equal to the sum of the interior angles given divided by 180 degrees plus 2. Okay, let us have an example. Example number 5. How many sides does a polygon have if the sum of its interior angle measures 1980 degrees? Okay, so in this given example, we have the sum of the interior angles, but we don't know how many sides does this polygon have. So in order for us to get the number of sides, we just need to follow the formula we derived a while ago. So n is equal to the sum of the interior angle, so which is 1980 degrees over 180 degrees plus 2. Okay, so we will simplify now. 1980 degrees divided by 180 is equal to 11 plus 2. Therefore, n is equal to 13. Okay. So it is a 13 gone. All right. Okay, now let us go to the sum of the measures of the exterior angles of a convex polygon, provided it is only one at each vertex, which is always equal to 360 degrees. Okay, so let us have an example number 6. How many sides does a polygon have if its exterior angle measures 24 degrees? Okay, so it's just very easy here since we know already that the sum of the measures of all exterior angles of any convex polygon w- provided it is only one at each vertex, is always equal to 360 degrees. So we just need to divide 360 degrees by the exterior angle given, 24 degrees. Therefore, n is equal to 15. Okay, so let us have another example. Example number 7. What is the measure of one exterior angle in a regular decagon? Okay, so we are looking for the measurement of an exterior angle given a regular decagon. So we just need to divide 360 by 10. So we have 36 degrees. All right. So there you are. So I hope you do understand our lesson about the sum of the interior angles, the measure of one of an interior angle of a regular polygon, and the measure of an exterior angle, and finding the number of sides given, the sum of the interior angles, or the measurement of an exterior angle of a regular polygon.